Good morning. Today we are going to work more with radical expressions, and we're going to do so by using what we know about rational exponents. So if those words sound alike and sound confusing, remember that radicals are the symbol that looks like this, the square root sign, or you could put a number out here if you want a cube root or fourth root or something like that. And then rational, remember that's the word that means fractions. So this means you would take something and write it as x to the 1/3 power. The root that you're taking becomes the denominator of your fractional exponent. So we haven't worked a whole lot with radical expressions. I mean, you've worked with square roots a bit in other math classes, but not really other roots, hardly at all. But you do know stuff about exponents. We have all of those exponent rules and things like that. So what we're going to do is use what you know about exponents to work problems that have radicals in them. So let me give you a few examples of this. So let's say that we had the problem, the fourth root of 2 times the fifth root of 2 to the 4th. Okay, so I don't really know what to do with those when they are in radical form. I don't know about how to work with radicals that are different from each other. Like if we had both fourth roots, it'd be a little easier to deal with, but we don't. They're different. So we're going to convert these over to rational exponents, and then we can apply our exponent knowledge. So this first term here, the fourth root of 2, I could write that as 2 to the 1/4 power. And then this second piece here, the fifth root of 2 to the 4th, I could write that as 2 to the 4/5 power. The 4 is your exponent's numerator, and then the 5, the fifth root, becomes the denominator. Okay, so if I look at the problem that I now have, this 2 to the 1/4 times 2 to the 4/5, so I'm multiplying and I have matching bases. So what do I do in that case with those exponents? So, well, we're going to keep that same base, so it's going to be 2 to the something. What do we do with those exponents? Well, we add them. So we're going to need to add the 1/4 and the 4/5. So I'll go ahead and do that off to the side here. If I want to take 1/4 and add 4/5 to it, well, in order to add fractions, we need common denominators, so that would be 20 in this case. So I'll multiply this by 5/5 and multiply this one by 4/4. Remember, whatever you do to the top, you have to do to the bottom. So this becomes 5/20 plus 16/20. And if I add those together, that would be 21/20. 21/20 is my fractional exponent. So a couple ways you might see this answer left. We could leave it like that. It's an improper fraction since 21 is bigger than 20. So you also might see this. You also might see, if you think of this as a 1 and 1/20 exponent, you could write this as 2 to the 1st times 2 to the 1/20. That looks a little bit more complicated, so it probably would be preferable to leave it with the 21/20. But I want to show you that because if you saw the answer in radical form, that's with the box looking thing, it would look like this. The 2 to the 1st is just a 2, but the 2 to the 1/20 would be the 20th root of 2. So you might see it like that too if they convert it back to radical form. If it doesn't say to convert it back to radical form, just leave it as a fractional exponent. Just leave it like this, and that's fine with me. So there's one problem. Let's see something else here. What if we had the cube root of 7 to the 4th over the fifth root of 7 squared. Okay, again, I have radicals here. They're different roots. Don't really know what to do with that, so let's change them to their rational exponent or fractional exponent form and then see what we know. So this numerator here, I could write that as 7 to the 4/3 power. So the root becomes the denominator of the exponent, I mean. Now I'm going to look at the actual denominator of this fraction, and it would be 7 to the 2/5 power if I write it as a rational exponent. So now I have a division problem. Remember, a fraction line means you're dividing. So what are we going to do to simplify this with these exponents? What exponent rule is going to kick into place here? Well, we're going to need to keep that base, so it's going to be 7, and then we need to subtract these exponents. So it's going to be 4/3 minus 2/5 is how I'll figure out what the exponent will be. So since we know stuff about exponents, we're applying that knowledge in this situation. So we need a common denominator in order to subtract fractions. So I'll multiply this one by 5, top and bottom, multiply this one by 3, top and bottom. So I get 20/15 minus 6/15, and that would be 14/15. So my exponent is 14/15. So there we go. So we used rational exponents in order to simplify the radicals. Let's see another one. How about, oh, this is a good one. The 6th root of the square root of c cubed. Whoa, this looks complicated, doesn't it? So don't freak out. We can do this. We're going to convert things to rational exponents. So this is a radical over a radical. So you know how when you have multiple sets of parentheses, you start with the inside set? Well, we're going to use that idea here. So I'm going to focus you on this inside part here. So let's take that square root of c cubed and change it into a fractional exponent. So that would be c to the 3/2. And then since that is getting 6th rooted, I'm going to write that as to the 1/6 power. Okay, so that changes both of those radicals into their fractional exponents. And so now we have exponents stacked on top of each other. A power to a power is the rule that we're having come into play here. And what do you do with the exponents in that case? Well, this is where you multiply the exponents. So we're going to be taking the 3/2 and multiplying it by 1/6. We could do a little canceling here with a 3 and the 6, make that a 1 and a 2. So when I multiply my numerators, I'm going to get 1. When I multiply my denominators, I'm going to get 4. So this would be written as c to the 1/4 power. Now I wonder if you saw these answers listed in radical form, could you identify what the radical form of that would be? Well, the denominator of the exponent tells you what root you're taking, so you could also write this as the 4th root of c if you wanted to. So that's another way to say that. When we have answers and we put them in radical form, we want to put them in what we call simplest radical form. So let's talk about simplest radical form for a minute here. So some rules for simplest radical form. One rule is we don't like fractions under radicals. So if you have something like this, let's say 1/2 under there, we don't like having fractions under radicals. So the easy way to do this is just deal with the bottom and the top separately. So I could write this as the square root of 1 over the square root of 2. Okay, just split it up into two problems. The square root of 1 is just 1. The square root of 2 I'm going to leave like that for now, but that's going to lead to another rule here. Another thing that we don't like is number 2. We don't want radicals in the denominator. Okay, so in the problem that I was just working on, right now I have a radical in the denominator. So here's how you are going to deal with that. So I'm going to bring down this 1 over radical 2. Okay, so I have a fraction here. You know how on fractions you're allowed to multiply the top and bottom both by the same thing? I call that a 1 in disguise. It doesn't change the value if you multiply the top and the bottom by the same thing. It just might change how it looks a little bit. So that's what we're going to use here. I'm going to multiply by a 1 in disguise. I'm going to use radical 2 over radical 2. Now, I chose that on purpose. The reason I chose it is I was looking at my denominator. Now, if you look at these denominators right here, if I multiply radical 2 times radical 2, that would be radical 4. Well, what is the square root of 4? Well, it's 2. So that makes my denominator just a plain 2. But whatever I do on the bottom, I also have to do on the top. So if I look up at these numerators, 1 times radical 2 would just be radical 2, and I'll bring that straight over. Okay, so that would be simplest radical form for this answer, square root of 2 over 2. Another rule that we have with simplest radical form is that's not number 2, is it? It's number 3. The radicand, which is the number under the radical, should be simplified. So for an example of this, let's say I had the square root of, I don't know, how about 75x to the 5th? Okay, 75 is not a number that I can square root nicely. This is just a square root, remember, because I didn't put a number outside of the radical, so it's just square root of 75x to the 5th. So if it doesn't square root nicely, your next step is to look and see if you can think of any factors of 75 that would be something that you could square root nicely. And 25 is what comes to mind for me. So I could rewrite this as a 25 times 3. So that's the same value as 75. So I'm not changing the value that I have. I'm just changing how it looks a little bit. Now x to the 5th is not something that's going to square root nicely, but x to the 4th would, which we'll look at that in a minute here. But I have x to the 5th. So I could rewrite the x to the 5th as an x to the 4th with an extra x behind it. So doesn't that still equal x to the 5th if I combine those together? It does. So here's what that does. I'm going to look at this in pieces. The square root of 25. Can I do the square root of 25? Yeah, that's just 5. So that's going to be out front. I'm going to put a radical here so I have some space to work. The square root of 3. Does 3 square root nicely? No, that's going to be stuck inside the radical. Then if I have the square root of x to the 4th, that would be x squared, because x squared times x squared gives you x to the 4th. And then this x that I have here, it doesn't square root nicely, so it's going to stay inside. So this would simplify. I probably should write those terms a little closer together, but it would be 5x squared radical 3x. That's what that simplifies to. So a fourth rule for simplifying with these is we don't like fractional bases with fractional exponents. Oops. So, like, we don't really like to have 3/5 to the 1/2 power. So it's too much to have fractions as bases and as exponents. So let's go ahead and split that up. 3 to the 1/2, and then 5 to the 1/2. So that is kind of like rule 1, where we don't want to have a fractional base, so I've taken care of that issue. But since 5 to the 1/2 is like having a square root of 5 over a square root of 3, now rule 2 is going to kick in. If we don't like to have radicals in denominators, then we also don't like to have fractional exponents in denominators, because they're like the same thing. So here, let me get rid of some of this extra writing that I have. So I'm going to multiply top and bottom of this fraction here, gotta be fair, top and bottom, by a 5 to the 1/2 power. That would be, in my denominator, that would be 5 to the first, because you would add those exponents. 1/2 plus 1/2 would be 1. And then my numerator would be 3 to the 1/2 times 5 to the 1/2. We can put those together and say that we would have the square root of 3 times the square root of 5 over 5, which would be the square root of 15 over 5. So that's how you would simplify that. And then a fifth rule, it's kind of more of a guideline, I would say. Mathematicians aren't necessarily really strict about this one, but we don't really want fractional exponents in denominators. And then a sixth one is we don't really want improper fractions as exponents. So those two, they're kind of guidelines, but it's kind of like, okay, so here's an analogy for you. In English, you know how there are some grammar rules that are like glaringly wrong? Like, oh my goodness, that is so terrible if you say it that way. And then there's other grammar rules that are kind of like, I don't know, it sounds fine. It's not a big deal. These two are kind of like I don't know, it's fine. Not really a big deal. Like, I suppose if you want to be very picky, we can follow those. But they're not like the glaring ones, like the first couple of rules are. So they're not that big of a deal. So I think that's everything I need to show you. So you have an assignment on Delta Math, I believe, today. So remember that Jesus loves you, and so do I, so do your math.